Hey everyone, and welcome. Today, we are going to dive into something that, let's be honest, we all wrestle with. That small group time at the kidney table. How do we make it truly powerful? We're going to talk about a pretty big paradigm shift, moving away from just showing kids steps to, actually creating a space where they build a real understanding of math for themselves. I absolutely love this quote from W.B. Yeats. I mean, it just gets right to the heart of what we're trying to do, doesn't it? Our job isn't to just pour information into our students' heads. Our real job is to light a fire, to spark their curiosity and get them excited about thinking and solving problems. So that brings up a really important question. If our big goal is to light that fire, why does our small group math instruction so often feel like we're just filling a pail? It's a huge disconnect, and I think it's one we've all felt. So let's dig into why that happens, and way more importantly, what we can actually do about it. Picture this, and I'm sure you can. We, the teacher, explain a step-by-step procedure. Then the students practice that exact procedure. And when a student gets stuck, which they will, our first instinct is usually to just explain the same procedure all over again, right? Maybe a little slower, a little louder this time. And this right here gets us to what we can really call the small group problem. Now, this teaching by telling method is super common, and it comes from a good place, but it has some serious drawbacks that can get in the way of the deep learning that we're really after. So what's really missing in that scenario? Well, it's the student's own thinking. We end up taking away their chance to think critically, to own their ideas, and to really make sense of the math. They learn to follow our recipe, sure, but because they never actually understood why the recipe works, the second you give them a slightly different problem, they're lost. But here's the good news. There is a much more powerful way to do this. And it all starts with us. It starts by reframing our own role in that small group. We need to shift from being the expert with all the answers to becoming a facilitator. So what does this shift actually look like? Well, we're moving from being a transmitter of knowledge, just beaming information into their brains, to being a facilitator of understanding. Our job is no longer to just hand them answers, it's to create the conditions and the space for them to find the answers themselves. It's a game changer. A huge part of this is rethinking how we help. We often rely on something called just-in-case scaffolding, and we do this with the best intentions. We want to prevent frustration, so we show them exactly how to solve a problem before they've even had a real chance to try it. We essentially do the thinking for them, just in case they might get stuck. Now, the more effective way to go is what we call just-in-time scaffolding. And here's the key. We wait. We let the students dig into the problem first. We watch them, we listen to them, and we only step in with a very specific, very targeted piece of support right when their struggle isn't moving them forward anymore. The help is precise, and it's exactly when they need it. And why is this so critical? Because the whole goal is to make room for productive struggle. This is the sweet spot. This is where the magic of learning actually happens. It's that moment when they're grappling with a tough idea, trying things out. That's where they build resilience. And that's where they make the connections that actually stick. Okay, I know what you might be thinking. This sounds great in theory, but how do I actually plan for this? What does this look like on a Wednesday afternoon? Well, I've got a really simple but really powerful framework for you, the TQE planning process. TQE. It's pretty straightforward. T is for tasks. We have to be super intentional about picking rich tasks that actually demand some thinking. Q is for questions. We need to go into the lesson with some great questions in our back pocket that will push their thinking, not just check and answer. And E is for evidence. How are we going to listen and watch for what they truly understand as they work? So, what makes a task a great task? Well, a few key things. It needs to have multiple entry points, so every single kid in the group can get started. It should have multiple solution paths, because we want to celebrate that there's more than one way to think about it. It's got to have high cognitive demands, so it requires some actual brain power. And, my favorite, a great task often is designed to bring out common mistakes, which gives us the perfect chance to talk about them. So once you've got that great task, the next piece of the puzzle is the conversation around it. This is all about making the student discourse, the math talk, as productive as it can possibly be. This table is basically your cheat sheet, your do this, not that guide.
On the left, you've got all the things we want to be doing, picking those awesome tasks, asking questions that make them think, providing that just-in-time support. And on the right, the things we want to try to avoid, like showing them the strategy right away, giving that immediate yes or no feedback, and relying on that just-in-case help.
When you boil it all down, the ultimate goal of all this work is right here, to shift the mathematical authority. It's about moving away from a world where we, the teacher, are the only source of truth. Instead, the authority for what's right and what makes sense rests with the students, with the community. They learn to argue, to critique, and to convince each other. All right, let's pull all these pieces together. Think of what we've talked about as your new framework, your new game plan for running small groups that can really change how your students experience math. So if you only take a few things away today, let it be these. 1. Embrace productive struggle. It's the engine of learning, not a sign that something's wrong. 2. Plan intentionally using the TQE process. Think about your tasks, your questions, and your evidence. And 3, and this might be the hardest one, give yourself permission to step back and let your students do the heavy lifting of making sense of the math. So I'm going to leave you with one final question to think about. In your very next small group, what is one small, concrete thing you can change to start shifting the focus away from your telling and onto their thinking? Maybe it's just waiting 10 extra seconds before you jump in. Or maybe it's just asking, how did you get that? Instead of, is that right? That one small change, that's the first step to lighting the fire.